How does a dying star create one of the strangest objects in the universe? Let's follow the entire story, from beginning to end. Every star is locked in a constant balancing act. Fusion in its core pushes outward, while gravity pulls inward. For most of a star's life, these two forces stay perfectly balanced, holding the star stable for millions or billions of years. But a star only has so much fuel. Eventually, for a massive enough star, it runs out. The instant fusion stops, the outward push disappears, and gravity finally wins. With nothing left to hold it up, the star's own mass begins crushing inward under its own gravity. This isn't a gentle process. It happens catastrophically fast. An entire stellar core collapsing in less than a second. For a sufficiently massive star, nothing known in physics can stop this collapse. It keeps shrinking and shrinking, with no floor. What's left behind is a black hole. All that mass, compressed into an infinitely small point. Around every black hole is a boundary called the event horizon. It isn't a physical surface. It's simply the point where escape becomes impossible. Inside that boundary, gravity is so strong that escaping would require moving faster than light. And since nothing can travel faster than light, nothing that crosses the event horizon can ever come back out. Not even light itself. That's why it's called a black hole. Imagine falling toward a black hole, feet first. Gravity pulls much more strongly on your feet, which are closer to the black hole, than on your head. This difference in pull, a tidal force, stretches you longer and thinner the closer you get. Physicists actually call this spaghettification. And for a small enough black hole, it would happen long before you ever reach the event horizon. At the very center of a black hole sits the singularity, a point where, according to our current equations, all the collapsed mass is compressed into zero volume. That means infinite density, a number that doesn't really make physical sense. It's a sign that our physics breaks down here, not necessarily what's literally there. General relativity and quantum mechanics both make extremely accurate predictions everywhere else. But at the singularity, they contradict each other completely. For decades, black holes were assumed to be permanent. Once something fell in, it stayed in forever. Physicist Stephen Hawking showed that quantum effects right at the event horizon cause black holes to very slowly emit particles, now called Hawking radiation. Emitting this radiation causes the black hole to lose a tiny amount of mass over time. Incredibly slowly, black holes actually evaporate. For a typical black hole, this process would take far longer than the current age of the universe. The black holes formed from a single dying star are relatively small, just a few times the mass of our Sun. But at the center of nearly every galaxy, including our own Milky Way, sits a supermassive black hole, millions or even billions of times more massive. How these enormous black holes actually formed is still one of the biggest open questions in astrophysics today. From a dying star, to a boundary light can't escape, to a point where physics itself breaks down. Black holes are one of the strangest things nature makes. Thanks for watching. Subscribe for more science Visualized.